today it's about what? It's Thursday, 12:30, lunchtime, and we've at Miami Curtain, we've decided to have a kind of a lunch and learn sort of segment or a series on what is it that consultants and architects and engineers do together in regards to new and existing buildings. And we'll likely stay on the subject of existing buildings today. And I'm here with a colleague, a very distinguished structural engineer, Frank Cuello. And Frank I've known now for at least 20 plus years, probably closer to 25, where we have been involved in every level of construction, from new construction to restoration and renovation, rehabilitation of historical buildings, as well as mid-rise tall buildings in Florida. And so Frank and I have become in the process very close friends. And I trust him profusely. In fact, one of the few engineers that I turn over control when it comes to certain aspects of work. I always get a second opinion, and that's one of the reasons I feel so comfortable with the work we do. So Frank, is here with us, and I hope to sort of talk about an aspect that's associated to a great deal of what's going on in South Florida, where we are very involved, which is the sort of the creation of this new city that's happening in front of us, and we're lucky to be part of it, and so I think that to keep this thing sort of focused in the subject that we're talking about today, we kind of named this series behind the curtain wall. What happens behind the curtain wall, and I suppose that it would be apropos to talk about for a moment what a curtain wall is versus other types of assemblies. And since most of these tall buildings that are involved, we are involved in some capacity, I think that we should sort of understand that the food chain, or the what is in the glazing industry, the most sophisticated glazing type of assembly, and that is the curtain wall. And underneath that is the window wall, that is like at the next level, and then punched windows and sliding doors and types of windows and doors that actually have moving parts. But the curtain wall and types of curtain walls are kind of the most dynamic type of assembly that goes on to many of these buildings that we're working on. Some are 50, 60 stories in South Florida. And so sort of describe the curtain wall. The curtain wall is like a machine. It's the skin, it's the epidermis of a building that is literally hung on the bones of a building. And the bones of the building would be the structure. And the structure is made up of columns and shear walls and PT cable slabs, cast in place slabs, and so forth. So the curtain wall actually hangs off the shoulders of the building, whereas a window wall is the infill panel that actually sits on a slab. And a punched window is a window that's within a masonry surround, and it's punched in. And we could go on with those sort of semantics, but I think that every so often we get and not, in fact, probably once a month, someone calls the office and says, "I need curtains for my house." And it's like, it's like we don't offer curtains, but I think the analogies of what a curtain wall is equivalent. You have a curtain rod. And the curtain rod would be the shoulder or the slab of a building, and the curtain wall hangs off the face of the building, as opposed to sitting on the ledge at each one of the floors. And each slab supports that curtain wall, its dead load of the curtain wall, and the dead load is the weight of the wall, and the live load is it has to deal with the live load of the building, and how that envelope that sits outside of the structure does both is where Frank pretty much gets involved in how to make sure that what we come up with as designs actually works. And so he's that set of eyes that makes sure that these things work. So Frank, wait, do you have any thoughts as to, that was a lot that I talked about, but do you have any thoughts about first of all, how we work together and how you're that set of eyes that really truly keeps track of perhaps things that I might miss?
No. Well, first of all, thank you for the kind words. We know each other for a long time.
Yep.
I think it's more than 20 years. Mm-hmm. So basically, every project has a different set of parameters and set of challenges. And basically, I have to look at in the prism of the code, and then work together with you and Maria and your team, your whole team. And it's a process, but I think we work very well together.
I think the best moments were when we're working together on things, and I'm going to say at least we've done at least 100 projects together, if not more. But I would say the most delightful times, or the times that I kind of enjoy the most, is that I'll have a theory that I'm pretty certain will work, and I'll lay out the theory on paper, and you'll look at it and very kindly say, yeah, that's a really good idea, but let me offer this other one up, and it's better. And that's where I don't say it out loud necessarily, but my cup runneth over, and that Frank is right there and gets it, and and sometimes he doesn't come up with the answer right away, but it'll take a couple of days and he'll come back.
Or I say it doesn't work, and,
Yeah.
and that's why I say it's a process. But usually the first go around, it's no. It's very aggressive, John.
Yeah. So we've I think that the fun part of this is the fun part is oftentimes with the owner exploring all of the possibilities in a project. But then later on, it's the development of that idea with your engineering team that you add clarity to what really matters. So it's like writing a story, and realizing that if you do a little bit of code or historic research, that there's something that may actually make the thing better and richer. And the better idea is the good idea. The better idea is always the good idea. So when I'm always capable of giving Frank enormous credit when he comes up with the better idea, and then utilizing it for the good of the project.
Yeah, well, we tried, but like I said before, most times when we start the project, it's it's a give and take, and most of the times I'm saying no, but we'll get to the point that meets the criteria, the design criteria.
Yeah, eventually, I think that what comes of the process is that when you start to explore all of the performance criteria that's required from, especially very aggressive coastal conditions on some of these buildings that we work on, that we're and especially those that we are rehabilitating the skin, no? That that it's somewhat like improving the skin on an old set of bones. It's like, I don't know about you, but I just turned very old on Easter.
You're a very young guy.
and I thought it's like, well, if I were going to do a facelift, I would have to contend with these old bones, right? I'll cover up those old bones, but there's a couple of ins and outs that isn't as easy as when you're doing a new building. So, for example, La Gorge is a project we were working on the curtain wall portion of the building, and it's an older building that its curtain wall has exceeded its life expectancy to a certain extent, and the glass has to be replaced for impact glass. It's at that crossroad of when these type of things has to happen, and so we're working on that design, and we're working on other projects that there's a life expectancy that you have to start to consider, where it becomes cost effective in being proactive and working on some of these projects. There are a number of projects that we've done, you and I, Frank, our office, where we're changing things out.
Yeah, we just finished the Brickle Place.
Yeah.
You told me it's a very nice set of drawings, and it's almost 200 pages of drawings.
Yes, Brickle Place is Brickle Place is one of those projects where it's two towers and townhouses.
Mm-hmm.
Right. It has a significant price tag, and what's wonderful of a Brickle Place type of outfit is that they're trying to be proactive in kind of extending the life of the building another 40 years or 50 years. So
right.
We've generated a set of drawings, and we're going through that process. And I think that one of the things we've done over the years is thinking out of the box. How can we make something that probably was built the first time with a technology that didn't exist back 30, 40 years ago, 50 years ago? And how do we introduce a better technology, which is what we're doing now, because of requirements in the Florida Building Code? No?
Yeah, and the code changes, as you know, periodically.
Yeah.
And you got to be on top of it, basically.
And what you've done is over the years is you have followed the changes in the codes associated to wind speeds. Now, why don't you tell me about how you go about that process of calculating the wind speeds on a coastal versus like a property that's inland?
Well, Right now we're following the AC 722, and you know, basically most of our buildings are exposure D, which is the buildings are close to the water, you know, within 5,000 feet of the water, or exposure C, which is, you know, you're beyond that parameter, you know. For example, anywhere in in Dade County, but let's say Old Miami Beach would be exposure D, and think Brickell, and we'll go from there. And for buildings greater than 60 feet, and depending on the shape of the building and all that stuff, we'll, you know, we work with you guys and calculated the design wind pressures.
And what's key, is that. Well, I think that I'm glad you're bringing up that the exposure D versus C. The rule of thumb I usually have is that if it's within like a mile of the coast, you're likely in the exposure D category. If you're on the coastline right there, right up to about a mile, that's about exposure D. So I have a general rule of thumb.
I think it's 5,000 feet or 20 times the size of the building. Right. Whichever is greater.
Right. So to give you a sense of what that means is that the wind load on a building on a coastal condition could be in the plus 100 PSF range.
If it's within the edges of the building, let's say when what we call zone 5s, which is a 10% of the, in simple terms, 10% of the smallest portion of the building. The pressure, the negative pressure, which is the suction within the curtain wall or the window, could be twice as much, almost twice as much as the interior windows and doors.
Yeah, because I think that when you interpret, what the engineering aspect to what is actually happening during a hurricane, you have the wind on the windward side of the building, depending on the rotation of that storm, on the windward side, and then you have the wind and you have the effects on the leeward side. So on the leeward side, that would be the glass sucking out. On the side where the wind is hitting it, that would be the pressure. That would be the positive pressure. Yeah. And then on the leeward side, it would be the negative pressure. Curtain walls and window walls are always stronger in the positive direction. The concern is on the negative side.
On the suction, which is the worst case scenario.
Which is the direction where an outswing door opens. It opens outward. So what becomes very key is if you have a set of storefront doors or a set of outswing doors, the locking mechanism is usually a locking mechanism that has 3 points of connection at the top, bottom, and the pin in the middle, or that the locking mechanism is sufficient to withstand that negative pressure if it's an outswing set of doors. A sliding door, the interlock between mullions, the interlock between panels becomes a structural component where the two stiles join together to divide the pressure in each panel. And that's how a sliding door actually works when the wind is sucking that door, trying to suck that door out. And, if you sort of visualize that it really matters a lot on a 50, 60, 70 story penthouse, where the wind there around the corners, at the intersections, at the roof line. That area is a zone 5. The pressures are much higher.
Much higher.
So, when you go out and buy that penthouse unit with the beautiful southeast views,
The city and the ocean. Yeah.
it's a beautiful view, but the wind comes in. That from that direction along the coastline here in Miami. I've lived here most of my life, like you have.
Yeah.
So that Hurricane Alley, what Hurricane Alley means, and there's a lot of people that have moved here lately over the last few years and haven't really gone through a Category 4, Category 5 storm, and the type of wind that's hitting a building, especially coming in from the direction of the southeast side, is like something you've never seen before. Now you've lived here most of your life, right?
Yeah.
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 So you've gone through a few. You went through Hurricane Andrew.
I went through Andrew. Yeah. That was no fun.
And one of the things that Frank and I have tried to do is when we're restoring these senior buildings that are kind of the pioneer buildings that existed in the 20s and the 30s, 1920s, 30s, 40s, 70s, is that we've come to a place where we understand that large missile impact and small missile impact is an advancement in glass technology. That the early architects and engineers, they couldn't use that. They couldn't necessarily use that back then because it didn't exist. But as a result of what happened in Hurricane Andrew, it forced the industry to become better. And we as architects and engineers, Frank, right? We feel we can say that we haven't lost a building because of a blowout that's resulted from high winds, especially these taller buildings. Right? So I wanted to sort of switch over and talk about I think something that's sort of fun is like how architects and structural engineers look at the same problem from different angles, and what our roles are in that process. And they're both very important, right? They're how an architect looks at the design of the skin of a building, the architectural skin of the building, making sure that it deals with what's called glazing. And glazing is simply the wedging in of glass with gaskets, or wedging glass into a frame with sealant. That's what glazing is. It's a very simple way of looking at it. So when someone says you're glazing assemblies, all curtain walls and window walls are glazing assemblies. And that glazing is what holds the glass in place. You can't mechanically attach, right? You can't put fasteners through glass because it'll break, right? So you got to wedge the glass in place. Same concept with the windows in your car, the windows in an airplane. They're not mechanically attached, all right? They're wedged into place with a very, very high levels of tolerance, or sophisticated levels of tolerance, so that the glass can move, but it won't break. Right? Kind of like a coconut tree. You let it. It can move. It could deflect. But as long as it comes back, it's okay. So what as an architect, what I do is I kind of try to understand what's the system that'll let my building go through the process of breathing, keeps water out, removes any vapor, doesn't allow moisture to get trapped in the wall, but allows any moisture that gets in to dry out and leave, because some materials absorb water, and then that water has to evaporate out somehow. It has to dissipate, right? So all of these things are part of the glazing of a curtain wall or a window wall or doors, etc. But an engineer, and you could tell us more about how the engineer looks at the same problem, but from a totally different perspective. And so why don't you tell me a little bit, Frankie? You're the expert at that, no? Or you're at least as expert as I am, I would say. We both look at the same things, but we have different concentrations that we like to get into.
Well, basically, I work as a consultant, and it's mainly dealing with the wind pressures on the system, on the curtain wall systems, and how to the different scenarios that we have to deal with. Like, for example, when we have to provide new headers, new sills, or new how it's attached to the existing structure, and what's the existing structure, and
See, because one of the things that happens with what we do is we'll get to an older building, and the moment you remove the old window, the header or the sill that was a precast piece that you used to buy and put in place, it just dismantles. It comes apart. The concrete spalls. It's destroyed. We've done a few of those buildings like that. Mm-hmm. And all of a sudden, the owner, the association thought they were just buying new windows. All right, and we're aware that these older buildings that were built in the 40s and 50s, even up through the 70s, they used to purchase pre-manufactured sills that had a certain profile that the window would sit into. All right. And then fasteners would go into those sills, and there was a couple of steel number 3 pencil rods in there. And when you pull those things apart, it takes out the sill. So what happened, and I think you could talk about it, how many times we've had to rebuild the certain parts?
No, you have to deal with restoration, structural restoration in all these older buildings. And deal as a case-by-case scenario, and it usually has to do with spalling, if it is concrete, or corrosion, if it's if it's steel. But it's very important nowadays to be sure that you're doing the right restoration process. And there are many products right now that we can use for restoration purposes, but that's very critical, and that usually happens when we remove, like you said, the product, and we have to put the new back, and nobody expects that kind of
no one expects
cost.
when you have about 700 or 800 windows, and all of a sudden you are thinking of one cost associated to windows. It wouldn't do you any good if you don't design a masonry opening that can receive those external stresses and bring those stresses through the building back down through into the structure, that it can withstand and resist those pressures, and we've had to not only build the sill up again, but run the reinforcement into the slabs, because the original project just had block wall with the sill. Mm-hmm. You're not doing anything if you're just installing a window and an opening, and the structure can't take those pressures and transmit them without damaging other parts of the building. And a good example of that is the code allows you to just simply take a window out and put the window in. But once you start changing the structure, no, okay, you have to add some components. You have to meet the criteria of the Florida Building Code.
Of the current code.
And say, okay, I'm going to modify a portion of the building to receive those internal stresses or external stresses that then become internal stresses, and those stresses are transmitted through the structure down to grade, right? So you're moving all of that force away from the facade without damaging the structure. And I think that's one of the things that by having you always part of the team, we're looking at how the structure will remain flawless, and that things can hang off of that building or be infilled into the system where you're not getting unexpected structural damage of some sort. Yeah, and I think there's also something that we do, Frank. I've been a very strong proponent of is, you know that we have in-house engineers that work in the office, but I've been a believer in that it's important to have a certain distance between disciplines, so that I could voice my opinions and not influence, and that I could hear a different set of observations, and not feel that an employee of mine would have to do what I'm saying, but in fact, I want to hear the possibility of something that I might not necessarily agree with at first. And so I think that it's really kind of important to have this ability to the scientific method of self-examination, that there's not a conflict, an inherent conflict amongst your team, And so I think that I've been, in my career now, it's at least 25 years. In fact, it's 30. You're right. The office opened about 30 years ago, the architecture office. And it's been 30 years that you and I have been working. That it's been a fruitful relationship, because I could always count on getting your independent opinion and not trying to sway you, but to listen. And I don't think that everyone does it that way,
Well, that's the way it should be, in my humble opinion.
Yeah.
And like I said, and your team is great. Your partners are great, so it's always a give and take, and it's a very good and healthy relationship.
Well, we've managed to tackle a lot of battles. We've tackled them together, and I've felt that when, especially during construction, one of the things that both of us we enjoy the construction part. And we like to see how these things turn into the projects we visualize. That we're well healed in the construction ends of things, so that if you go out and you see something, or I go out and see something that's a little suspect, we immediately know that we need to curb something. I don't think everybody has that type of experience in the field, where you're walking around and you're looking at something and say, wait a minute, I don't think I've seen that before. That looks a little strange to me, And we've run into those things on some high rises. Stuff that was done maybe 50 years ago, there's no record of, and you open up a building and there's this design that nobody can explain why. Why? I think that happened to us at Villa Regina on that expansion joint.
No,
Remember?
you have better memory.
Yeah, that was
than I-
that was kind of that was one of these processes that over the years on that building, it was about 50 years. You know, that building is an older building. It's built in the 70s. Villa Regina, the colorful one. That's the colorful one with that looks like a rainbow of colors. A beautiful building. We did the restoration of the building, and then we
Right.
did the lobby. We did a number of things there. But as we were restoring the stucco and dealing with the concrete restoration and the cracks and so forth, that we were removing material stucco cladding from this. I think the building's like 30 plus stories tall at least. Now we started removing stucco. It became evident that in the life of that building, they had a condition that they tried to repair multiple times, and they just packed it with stucco, and they just smashed the stucco into this hole that happened all the way up the building vertically, and it showed up on one side of the building and on the other side, and you know, we went back to the drawings. We didn't know what it was because it didn't show up in the drawings, and it was some sort of engineered expansion joint that was 50 years old. And the way that the owners of the association had dealt with it is when they would paint the building, I guess they just stuffed it with material, but then it would wind up cracking and falling apart and flaking and so forth. So we spent at least a couple months, month and a half, engineering a new solution to that existing condition on the whole of this building that as I understand, still held up pretty well, and it's been about 10 years, 10 years now. So
The lobby came out really nice, and
Yeah.
the
yeah.
reflecting pool.
we did some neat things
Yeah.
there. We did the lobby. We did the architecture interior design of the lobby, and we reformulated the access or the approach where we detailed and we designed the entrance, and now we're you and I are doing Costa Brava together, which is going to be a fabulous new project. And that has its own
Set of challenges.
of issues. But I think that at Costa Brava we're going to be doing glass railings along the ledge or the edge, because that's another technology that 50 years ago, 50 years ago, people did not install glass railings because there was an inherent fear of the glass falling out and you falling out with it. And now everywhere you go, in Miami or in South Florida and even Florida, you have glass railings that using the technology of lamination and the sort of the plastic insert or the laminate that happens in the composite glass. You could have a kid run in head first into a piece of glass that's a railing, and yeah, it'll break the glass. Glass is, will break, but it won't fall out, and it'll keep the person in. But I think that even the way how people look at aesthetically at the environment, especially on tall buildings and the technology of tall buildings in Florida, South Florida, along the coastline, people do not want obstructions, and they want to be able to see the ocean and the urbanism without pickets and rails. there was a time that you felt safe with pickets and rails back in the 60s and the 70s. No one would have ever put glass railings back in the day because your psyche was, I have to feel safe. I'm up on a tall building, and God forbid the glass might fall out, and I'll fall out with it. Right? That was the idea. But now everyone wants a clear view to the ocean, especially if you have you're somewhere in an upper floor.
Yeah. Of course.
Or you're at the amenity deck of the pool, and the podium of a the podium would be the parking garage, and above the parking garage you have the pool, and then you want that glass so that as you're sunbathing you can see the ocean. You feel like you're part of the ocean. So I think that we'll be doing that at Costa Brava a lot. We're going to be putting in that kind of technology, but that's a technology that didn't exist in the 70s. Let's face it. These older buildings that are coming to that 40-year recertification, the certification process that in fact changed after Champlain Tower. That we're making buildings better. So we're using those shells, those structures, and we're recladding and resurfacing and reinstalling a new appearance that didn't exist when those buildings were done. And I think those original architects of those older buildings never expected that their buildings would look that much nicer if they didn't have all those pickets and those, they used to have those old concrete balustrades that were very deco-like. They look actually cool in some of those, in some of the older deco buildings. But for the most part, those balustrades, most of that stuff is being removed.
Yeah, and replaced with glass. That's
And
right.
replaced with glass. So I would say that we are on the cutting edge of technology, my intention is to kind of do these little fireside chats, and creating a series where we can sort of talk about some of these ideas, and hopefully, if you want to hear more, through LinkedIn, you could catch our next episode of Behind the Curtain Wall, where we actually will cover some other subjects that have to do about new and existing buildings and reskinning, you could say, reskinning the exterior of buildings that are going through a 40-year certification process, or the regular certification process, or new construction. How do you install a brand new architectural skin that and so that I hope you guys will follow us on LinkedIn. Thank you, Frank.
Thank you, John, for the invite. It was a pleasure. And
thank you for joining me today. You're great to start with this series, since we've done so much together. Thank you so much.
Thank you.